Hello, everyone, and welcome to my class. Today we will still be working on algebra problems, of course. Yes, because algebra is important, and that's why. So, without further ado, let's begin this class. So, I shared my screen, so hopefully you can see my screen. Say yes if you can see my screen in the chat. Who can see my screen? Come on, people. It ain't that hard. So no one can see my screen. Oh, Sophia can. So only Sophia. No one else. Oh, Steven isn't here today. He's late. Well, Reza finally showed up. Okay. So, algebra problems 4. Very boring indeed. So our schedule. Very packed schedule there. Mathematical symbols, because we all need a little bit more of that. Rapid multiplication and addition methods, because you're too slow. Complex numbers, because, the creators of mathematics, oh, this is too simple, let's make it more complicated. That's why. Unique equations, if there's still time. There's probably not enough time in the world. I mean, yeah. So, any questions on the schedule? Don't tell me I'm muted all the time. No, I'm not muted. Oh, that's nice. It's a first. Okay. Wait, what? I'm muted? No, I'm not. Okay, so let's begin. And, of course, yes. Yep. And Steven has still not shown up yet. Of course. So late. When is he ever late? It's always the first one here. All right. So now we will go over mathematical symbols. Letters and stuff. Fancy letters. So, does anybody know anything about mathematical numbers? Anything? Come on, people. See, not that hard. Huh. Numbers. What are some mathematical numbers? Okay, I'm going to teach, so I think I'm going to do all the work here. All right. I'm going to teach you the basic mathematical symbols, which is basically numbers. It's just easier than to actually write out the words. For example, if you're going to say A is real, which basically means A is a real number, it's easier to just do, oh, come on. A is real. You can write that with mathematical symbols. What is this? This keeps popping up. All right. Yeah. So, now let's do this. Basically, our first symbol here is, why is my pen doing this? Come on. Literally. Maybe a different spot will work. All right, that still looks fresh. Hold on. All right. An R. Basically, what R means is that it is a set of all real numbers. All right, it's a set of all real numbers. So when you're trying to denote that a number is real, then you can use R. And why am I touching up on this? Is because we're going to use this later. It's just easier to just use mathematical symbols when you're talking about things fast. So that's why. You're going to learn these later on anyway, so Might as well learn them now. And also, if you use mathematical symbols, they make you look smarter. So that's why. That's the main reason, though. All right. So, in real numbers, we have rational numbers and irrational numbers. All right. So, in these curly brackets, they basically mean a set of objects. So, rational numbers, the mathematical symbol for that is going to be Q. All right. Q. And then we also have irrational numbers, basically like square root of 2, square root of 3, pi. Basically what they are like they're just never-ending decimals, and that's why they are irrational. And we're going to talk more about these number theory topics in some later classes, proving why square root of 2 or square root of 3 is irrational, and just learning about a lot of theorems and manipulating numbers a lot. So get ready for that. What, you're not excited? Well, too bad. Okay, so irrational numbers are denoted, actually there's a lot of ways you can denote an irrational number, like IQ, but we're not going to use that because that basically, IQ also stands for how smart you are. That does not relate to this topic. So we're going to use another mathematical symbol called P. Don't take that too literally. All right, so now more about Q. As I said, rational numbers basically are, how to explain this? Okay, so rational numbers are P over Q, in which P and Q are integers. All right, they're integers. And then Q does not equal 0. So that is what a rational number is. So basically, like a terminating decimal, well, that's basically P over Q in some sort of way. And then 3, that's just 3 over 1. So it is a rational number. Now, square root of 2, that is a never-ending decimal. So therefore, it can't be denoted in like this P over Q form, where P and Q are integers. And then we also have repeating decimals, like 0.16 repeating. That's basically just 1/16, right? Yeah, it's 1/6. And because these, or it can be like, it can just be, there are also rational numbers such as decimals, like 0.2565 and then da da da. But then at the end, it starts repeating. That's still some sort of fraction. So any number in the form P over Q, where P and Q are integers and Q does not equal 0, then that is a rational number and fits in the set Q. And if you're wondering why Q cannot be equal to 0, well, if it's equal to 0, then it's going to be undefined. So that's not even a real number. And P, that's basically sets of numbers, real numbers that don't fit in Q, such as square root of 2 or square root of 3. They are non-terminating, never-ending decimals, or pi. All right, so Does anybody have any questions on these mathematical symbols? Are there any questions? No questions, hopefully. Hopefully you're taking notes or something like that. Is everybody taking notes? No? This is sad. Okay, so multiplication and addition laws for real numbers. All right. Okay. So let's touch up on some addition laws. All right. These are very useful when you're working with algebra. You need to know how to manipulate numbers, I guess. I don't know. Anyways, a plus b equals b plus a. All right, that's very useful. I'm assuming you already know this. These are very basic laws, but there are some in there that you might not know. And I'm sure this is called some kind of property, but I can't remember which one. So that's sad. Anyways, the second one is no, this is the commutative property, right? Yeah, that's the commutative property. Correct me if I'm wrong. And then since that's the commutative property, we also have the associative property. A plus B plus C equals A plus B plus C. And we just switch the sets of parentheses. Number 3 is A plus 0 equals 0 plus A. All right, which equals A. And that's just kind of common sense. How would you not know that? So number 4 is for any real number, all right, there is B, which is also a real number, okay, such that A plus B equals 0. And that B is called the additive inverse. Come on, where'd it go? Okay, the additive inverse. All right, so these are the 4 laws about addition. The 4 laws for real numbers. Okay, and then we also have multiplication laws, but I'm not going to touch up on that yet. Do you have any questions before I go to the multiplication laws? And also, if you're wondering, this symbol means an element of. Okay? Sorry, I didn't touch up on that. All right, an element of. So basically, if 3 is a real number, then 3 is an element of the set real numbers. So that's how we use that. So does anybody need me to go over any of these laws? Do you understand them? Say yes if you understand. If you don't say yes, I'll assume that you haven't been paying attention the whole time. So nobody has been paying attention. Oh. Okay, that's sad. It's very sad. Chat is so dry. I'll pour some water on it. Okay, so number 5. This is similar. This is basically actually the same thing. This is also commutative property, but this is for multiplication. So A times B equals B times A, and B A, B, C are A, B, C are real. All right, A, B, C are real. So, and then number 6 is the associative property, which is A times B in parentheses times C equals A times the quantity of B times C. All right, so our seventh law is A times 1 equals A. That's just common sense, like A plus 0 is A. And then number 8, our last multiplication law is that for any A does not equal 0, there is B such that AB equals 1. And that is basically B equals A to the negative first power, which is 1 over A. And then that is called the multiplicative inverse. Yeah. Not sure if I pronounced that correctly. So, why is this keep popping up again? All right. For any A does not equal 0, there is B such that B equals 1. And B equals A to the negative first power, or 1 over A. And that is called the multiplicative inverse. Now we have a 9th law here. Hold on. And this ninth law combines addition and multiplication. And that is going to be the distributive property. A times the quantity of B plus C equals AB plus AC. So I would like you to take a moment and just take in all of this. Take notes about it. All right, these laws are pretty important. If you do not feel like you need them, then simply don't take notes. I mean, these are just common sense. A times 1, of course that's A. But there's some there are some pretty useful laws in there as well, so you might as well like remember them, like distributive property. Definitely gonna use that one in algebra. So I'll give you like couple moments to take notes. First of all, are there any questions on this? On these laws? Are there any questions? No questions. Come on, people. Oh, Edward answered finally. Where's Steven? Oh, are you longing for your rival? Apparently he died somewhere, so he's not coming today. Of course, yes, you're longing for your rival. Huh. Wait, what? He was alive 30 minutes ago. What do you mean he was alive 30 minutes ago? I never saw him here. What? Alright. We're always in the same class. Wait, you go to the same class? Oh. What was your previous class? Math again? That'd be very sad. Easy math. Oh, yeah. Wait, why do you even take that class then? If it's that easy, why do you take it? What is it even? Okay, so Well, moving on, rapid multiplication skills. Let's do this. So, can anybody tell me what is 5 squared? What is 5 squared? What is 5 squared? People, come on, it's not that hard. $25, yes. Yep, 25. So nobody else knows the answer to 5 squared. Where are you in this class then? If you don't know the answer to 5 squared, go back to kindergarten. Oh wait, they don't want this in kindergarten. That's sad. All right, 5 squared is 25. Now what is 15 squared? What is 15 squared? Come on, people. What is it? Yes, 225. Yes. 225. And then what is 25 squared? Does anybody know what 25 squared is? Yes, 625. Okay, so now let's do some harder ones. What is 35 squared? What is 35 squared? Huh? 35 squared. Come on, people. It's not that hard. No using calculators, people. Oh, 1,225. Yes, correct. Now, can you answer in 5 seconds? What is 45 squared? 5, 4, 3, 2, 1. Wow, very fast. 2025. Yes, it's going to be in 4 years. 2025. Now, I'm going to show you 55 squared is going to be equal to 325. 65 squared, 4225. All right, 85 squared. Sorry, we just skipped 75 squared. No room. 7225. All right, can you see a pattern here? No, you can't actually, because we're not looking to see patterns. This is how you rapidly multiply. So does anybody know what I'm doing to get the answers this quick? How do you get the answers this quick when you're multiplying, when you're getting the squares of 5? How do you do this? I think, oh, you think you know, huh? You think you know, so you don't know. You think you know, but you don't know. Go back to the page. Oh, how do you do it? Huh? Come on. It's not that hard. Oh, wait, there is a pattern here. I'm starting to see it. This sad. There is a pattern here, right? What is this? X 5 squared equals 100 times x plus 1 plus 25. Huh. Huh. Round of applause for Sophia. Very nice. That is exactly how you do it. Rapid multiplication. Yes. Alright, so let's do this. So basically, what you do is don't pay attention to the pattern you see here. Every time you're adding, what is this? This number right here. You're adding something, right? Don't pay attention to that pattern. This is plus 2, this is plus 4, plus 6, plus 8, plus 10, plus 12, plus 14, plus 16. All right. Don't pay attention to that pattern, even if you've seen it, because that's not what we're going to do. I mean, you're not going to recite that pattern every time. You're going to do it. So, what you need to do when you're doing this, all right? Let's do 85 squared. How do we get that? All right. 85 is 80 plus 5, right? 80 plus 5. All right. So, what you need to do is you just need to multiply this out. And you see here that is going to be 640, 6,400, actually. Yes, 6,400 plus, actually, let's write it this way. 80 times 80 plus 5 times 80 plus another 5 times 80, that's 10 times 80 plus 25. All right. So basically what this is 80 times 90 plus 25. So the rough formula every time you get this is you need to, every time you do this, you need to take this first number here and then let's 55 squared, right? 5 times 5 plus 1. That's what we're doing here. And then we're going to multiply that to that number plus 1. That's going to be equal to 30. And then we're going to add this 25 to it. So we get 3025. And that is exactly what Sophia told us, right? 100 times x plus 1 plus 25. Right. But yeah, that's the fast method. Yeah. So we can also try this with other like other squares, right? Like 14 squared. Then what is that? That's 10 plus 4, 10 plus 4. 10 times 10. All right. And then what? Okay, so plus 10 times 8. Okay. So after you do that, just add a 16 to it. All right, but it's always faster with 5 because you're just with 14 you're adding 10 times 8, but with 80 plus 5, when you're adding 4, you're like adding that number times 8. But when you're like adding 5 to this, then you're adding 10 times that number. So it's always easier when you have 5. But with that aside, this method is always the fastest. So whenever you are trying to trying to rapidly multiply something, then this is what you do. All right, so some other things. All right, let's try some other problems besides. Actually, I want you guys to let's actually practice a bit more with this. What is 115 squared? What is that? It's gonna be a very big number. 5 digits. Yes, 132.25. So what you do is this equals 110 plus 5 times 110 plus 5 again. And then you see here it's basically 110 times 120 plus 25. And that is exactly like Sophia's formula, 11 times 12 times 100 plus 25. Okay. And that is basically 132, 100 plus 25, 132.25. Very good. So, actually, there's another problem we can touch up on. So, for example, we have 113, right? Plus, actually, multiplied by 117. All right, that's just basically 110 plus 3 times 117. 110 plus 7. All right, and then that's what you do. Now, our last type of problem we're going to go over today is 19 times 21. How are you supposed to do that? Does anybody know? How are we going to do that? Okay, come on, people. It isn't that hard. Yes, very good. Difference of squares, 399. You're very good with rapid multiplication, Sophia. Good. 20 minus 1 times 20 plus 1. What is this? Okay, when we have x plus y times x minus y, that's going to be equal to x squared minus y squared. That is difference of squares, and that is exactly what we are using here. Why does this keep popping up? Stupid. All right, so basically, what is x squared? 400. What is y squared? 1 minus 1 equals 399. So good. So that is how we do that. So now let's move on to rapid addition skills. 1 plus 2 plus 3 plus 4 plus ... plus 100. What are we going to do now? What does that equal? Okay, how are we going to solve this? Wow, this is so hard. How are we going to solve this? No, it's not hard. Come on, people. I'm sure some of you know this. Oh, Edward and Sophia, very good. So, how did we solve this? All right, how do we solve? Oh, Edward has another chat. Big easy. Yes, of course. So, basically, let's write it backwards. 100 plus 99 plus 98 plus 97 plus ... plus 1. What is this? What is this? You see here we have 101 plus 101 plus 101 plus 101. No, that's a 100. 1 plus ... plus 101. All right, that's what we have here. So let's just add it up. I mean, we have 100 numbers here, 1 through 100, right? So 101 times 100. But we're not done yet. We have to divide that by 2 because we have 2 sets of these numbers. So we need to divide by 2. That's why. So it's going to be 101 divided by 2, which equals 5050. All right. We're done here again. So are there any questions about the method I used? Any questions? Now that is something you cannot use by calculator. You'll probably get it wrong using calculator. So no way to cheat there. So let's do another one of those, except this time we are going to skip some numbers. Let's see who gets it correct first. So our second problem is, let me erase this first. Okay. So 3 plus 7 plus 11 plus ... plus 99. Okay, this is a arithmetic sequence. It's an arithmetic sequence, basically a pattern. All right, this is a pattern. Okay, you see, it is increasing by 4 every time, these numbers. All right, so let's do this. So let's start. How do we do this? Does anybody have any idea how we are going to do this? No ideas. Oh, that's sad. I'll give you a few moments. Hopefully Sophia or Edward will solve this. Right. Don't look at you. Right. Yes. Just for information, Sophia, it is not 2,448. It is 1,275. Too bad. So sad. All right. So how do we do this? The same thing. Come on, people. Just write it backwards again. 99 plus, what's the next number? 95 plus 91. Which is decreasing by 4 every time. Right. So what we get every time is we get 102. Okay, 102. All right, we get 102 every time. All right, we get 102 every time. So basically, it's just going to be 102 times the number. How many numbers do we have here? All right, let's count. 3, 7, 11. No, we're not going to count like that. How we get the number of numbers in this arithmetic sequence is we need to, it doesn't start from 1, right? So you can't really like can't really count like that. So 99 minus 3 first, okay, that's 96. And then divide by 4. Yes, we're increasing by 4 every time, right? Divide by 4, that is going to be 24. But then, let's see. We didn't actually include the first number 3, right? So 24 plus 1 equals 25. So 102 times 25 over 2, all right? Your mistake, Sophia, is that you first didn't forget to count. You forgot to count 3. And second, you forgot to divide by 2. So why do we get 25, all right? How many numbers are 0 to 9? How many numbers? I mean, well, 9 minus 0, that's 9 numbers, right? No. Let's count. 0, that's 1 number. 1, that's 2 numbers. 2, that's 3. That's 4, that's 5 numbers. And then 5, that's 6 numbers. 6, that's 7. 7, that's 8 numbers. 8, that's 9 numbers already. 9, that's 10 numbers. So when you're trying to count how many numbers there are, we didn't actually let's say when you're playing a board game, right? These are your squares. You have a character trying to move your character to another spot, right? You start from this square, right? 1, 2. You don't start from this square and start counting. You move to this square and start counting. All right. This is not already 1. This is 0. So when you're playing the board game, you don't actually count this one. Okay. So that's why you need to plus 1 when you're counting like pages to a book or counting how many numbers there are. So with that aside, we should now know how to get this answer, right? Because that is going to be 2, I think so. Hold on a second. 25, 2550 actually. Over 2, right? Because you see here 100 times 25, that's easy, right? Because there are 4 25s and 100, so yeah, and 4 25s make 100, so we get 2,500, and then add that 50, right? Then divide by 2. That equals 1,275. Hopefully my math is correct. Let's see. Yes. All right. So do you understand your mistake? Come on, people. All right. So you don't understand your mistake. Oh, that's sad. So now let's review complex numbers. Yes. Numbers. No, let's not do that. We have all had enough of complex numbers. That's too boring. Let's do that next time. Anyways, yeah, let's do these. Let's move on to unique equations. I think that applies to today's lesson more. So let's begin with number 2. 3 plus the square root of 3x plus 1 equals x. Find x, please. Come on, people. Yes, it's not that hard. I'll give you a few moments to think about your life choices and also this problem. And then I'll come back and check your answers. If there are any. Usually they aren't. There aren't any answers here. Of course, because Steven's around, and like he's the only one that knows how to answer these. That's sad. Okay, any answers? Of course. This is sad. No answers. Whoa, Edward. Huh. 1 and 8. They're absolutely incorrect. Well, half of your answer is correct. Where'd that 1 come from? Check your answer, please. Yes, good. Round of applause to Edward. Yes, very good. I mean, like, 1 is an extraneous solution, so doesn't count. Doesn't count. All right, let's do this. This is going to be a quadratic equation. Because we're going to square things, right? There's square root, so naturally, try to get rid of it. So let's do that. Move 3 to the side. So it's going to be square root of 3x plus 1 equals x minus 3. And then let's square both sides. Because we don't want that square root. So let's do that. 3x plus 1 equals x squared minus, hold on, minus 6x plus 9. All right. And then we get x squared minus 9x minus 8 equals 0. Okay. And then what we get is, wait, let me check. Yeah, that's correct. Yes. All right. So after that, what we get is we factor this, right? Or you can use quadratic equation because this is now a quadratic formula. Excuse me. Okay, I am not my true state today. All right, this is sad. All right. So after that, you're supposed to hold on a second. I see. That's sad. So because it's such an easy quadratic equation, I'm gonna factor this to the x minus 8. All right. So one of them has to be equal to 0, right? Because of the zero product property. So x equals 1 or x equals 8. So why do we need to check? Because -1 does not equal 1, right? But when you square things, they are equal. So when you square things, when you square this, when you put the square here, it just mess things up. Why is my pen acting up again? So let's check. 1. 1 does not work. 3 plus 2 does not equal 1. But 8 works. So 8 is the correct solution. Very good, Edward. And since, yeah, thank you for correcting me. Yes, plus 8, yeah. Were you raising your hand, Edward? No, you aren't. Well, anyways, because the second question is going to be quite long, quite hard. I have to explain how to divide a polynomial to you, so we're just going to do that next class. So, yeah. This is the end of our class. Going to end pretty early today. So, thank you for listening. Bye, people. This is your cue to leave. Actually, I'm going to leave first.